Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson on the equation of a sphere. In the last lesson, we learned about three-dimensional coordinate space. We learned how to plot points in space, how to find the distance between them, and how to find the midpoint of a segment. Today, we will be learning about spheres and their equations. If you are ready, students, we will begin. We all know what a sphere is. When we talk about a sphere, we may be discussing a soccer ball, a piece of fruit, or even the moon. If we wished to plot a sphere mathematically, how would we do it? First, let us be reminded of the equation of a circle. When the center of a circle is at coordinates h and k, and its radius is r, the equation of the circle looks like this. We see here how C is the center and P is any point on the circle. R is the radius of the circle, or the distance between C and P. This is not too difficult, students. Now, what if we take our circle and project it into three-dimensional space? Now we have a sphere. A circle is defined as a shape consisting of those points in a plane which are equidistant from the center. With this in mind, how would you define a sphere? Please write your answer down now, students.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. We can define a sphere by expanding our definition of a circle. A sphere is a set of all points in space that are equidistant from a fixed point. The fixed point is called the center, and the common distance of all the points of the sphere from the fixed point is called the radius of the sphere. You may not have written your answer in exactly that way, but if you expressed the idea correctly, well done. Let us consider this sphere and say that the center is also the origin point of space. Its radius is 2 units long. Remember that the center point is located in space by coordinates x, y, and z. If r equals 2, then the equation of this sphere is expressed as x squared plus y squared plus z squared, which is equal to 4. Notice that the sum is equal to the radius squared. We can also work backwards, finding the distance of a point on the surface from the sphere's center. If we call the distance d, then it is defined by the square root of the equation of the sphere. In this case, the square root of the sum of x squared, y squared, and z squared, which is 2. Now, let us suppose that we do not know the radius of the sphere. We only know that its origin is the center and that a point on the sphere's surface is located at the coordinates 3, 4, and 0. The distance of P to the center O is the radius, which we will call R. In that case, R is equal to the sum of the squares of the 3 coordinates. For this sphere, R is equal to the square root of the sum of 3 squared and 4 squared, which is 5. We have learned how to equate a sphere whose center is the origin point. Now, we must study how to do the same for a sphere that does not originate from the center of space. Here, we have a sphere. As you can see, it is similar to our old sphere, but this time its center is located at coordinates 1, 2, 3 from the origin. The radius of the sphere is 4 units. Let us learn how to calculate the equation for this sphere. We see that P is at coordinates x, y, and z. That means the distance from the center to P is given to be the radius of the sphere. Therefore, we can express the equation for the radius like this. The value of r is already given. So, we can further refine our equation by adding its square. Remember the formula for the sphere that had its center at the origin? You can see how the new equation reduces into it when we substitute the variables a, b, and c for 0. That means the equation of a sphere given by this equation can be applied to a sphere whose center is at any point, including the origin. It is time for an activity, students. This is the equation for a sphere. Given this equation, find the center and radius of the sphere it describes. Please get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us look at your answers together. Here is the equation of the sphere. Following our steps, the equation becomes x squared minus 6x plus y squared minus 4y plus z squared minus 10z equals negative 22. Then x squared minus 6x plus 9 minus 9 plus y squared minus 4y plus 4 minus 4 plus z squared minus 10z plus 25 minus 25 equals negative 22. Simplified, the equation becomes x minus 3 squared plus y minus 2 squared plus z minus 5 squared equals 16. So, the square root of x minus 3 squared plus y minus 2 squared plus z minus 5 squared equals 4. We have found our answer. The center of the sphere is at 3, 2, 5, and the radius is 4 units. Good work, students. Remember, if the center of a sphere is the origin and r is its radius, then we have 3 possibilities for any point taken in space. If the distance between the origin and the point is greater than the radius, the point is outside the sphere. If the distance is less, it is inside. If the distance is the same, it is on the surface. Check the examples on page 284 of your textbook to explore these ideas further. That is all the time we have for today's lesson, students. We have learned how to express the equations of spheres in coordinate space and locate points relative to those spheres. Until next time, thank you, teacher. Thank you, students.